Good morning, students. Welcome back to SK online class of mathematics of class 12. Today we discuss next part of integrals which I discussed in my previous class. Today we discuss integrals of some particular functions, and the particular functions are: number one, this type function, that is integration dx by x square minus a square equal to 1 by 2a log mod x minus a by x plus a plus c. Number two, integration dx by a square minus x square equal to 1 by 2a log mod a plus x by a minus x plus c. Number three, integration dx by x square plus a square equal to 1 by a tan inverse x by a plus c. Number four, integration dx by root over x square minus a square equal to log mod x plus root over x square minus a square plus c. Number five, integration dx by root over a square minus x square equal to sin inverse x plus c. And at last, integration dx by root over x square plus a square equal to log mod x plus root over x square plus a square plus c. In all cases, c is the integration constant. I proved some of this theorem. Number one, proof integration dx by x square minus a square equal to, we can write this in this way, dx by x plus a into x minus a. Now 1 by x minus a minus 1 by x plus a. In this way, that means x plus a, doing LCM x minus a to x plus a, and numerator then x plus a minus x minus plus a. Okay, x cancel, 2a. 2a present here, only numerator show outside 1 by 2a. Okay, 2a cut, dx equal to 1 by 2a. Integration dx by x minus a means log mod x minus a minus integration dx by x plus a means log mod x plus a plus c equal to 1 by 2a log mod x minus a by x plus a plus c. In this way, we can prove this first one, and in the same process we apply in second one. Okay, number three, we try to prove integration dx by x square plus a square. Okay, at first let method of substitution we apply here. Let x equal to a tan theta, then therefore dx equal to, that means dx d theta equal to a ddx of tan x sec square x, so dd theta of tan theta sec square theta, and d theta this side d theta. So in place of dx we put a sec square theta d theta by x square means a square tan square theta plus a square. If we taking common a square from denominator and numerator a by a square equal to 1 by a, outside integration we put, then 1 plus tan square theta equal to sec square theta, and numerator sec square theta, both sec square theta cut only. Okay, write one time, sec square theta d theta by 1 plus tan square theta equal to sec square theta, cancel, equal to 1 by a into integration d theta equal to 1 by a theta plus c equal to, if x equal to a tan theta, then tan theta equal to x by a, and theta equal to tan inverse x by a. So 1 by a in place of theta we put tan inverse x by a plus c. C equal to integration constant. In this way, all theorem we prove. So now erase this. Now we solve some problem where we apply this type of method. As per NCERT book, it is exercise number 7.4. First one, integration 3x square by x to the power 6 plus 1 dx. At first we put x cube equal to z, then therefore 3x square dx equal to dz. So in place of 3x square we put dz by x to the power 6 means x cube whole square. X cube whole square means z square plus 1 equal to dz by z square plus 1 means a square. So tan inverse x by a means z by 1 equal to z equal to c plus c equal to tan inverse z means x cube plus c. Tan inverse x cube plus c. First one. Now just question number 4, integration dx by 9 minus root over 9 minus 25 x square. Okay, dx by root over 9 minus 25 x square. Okay, let's start. From denominator we just take common 25 and outside 25 equal to 5 5 is 25 dx by root over then 9 by 25 minus 3 by 5 the whole square minus x square. Okay, then it is the form dx by root over a square minus x square. We know it is sin inverse dx by root over a square minus x square equal to sin inverse x by a. So 1 by 5 sin inverse x by a means 3 by 5 plus c equal to integration constant equal to 1 by 5 sin inverse 5x by 3 plus c. Now on another math we do here question number 9, integration sec square x dx by root over tan square x plus 4. Method of substitution we apply here. Put let z equal to tan x. So dz equal to dx of tan x sec square x dx. So in place of sec square x dx we put only dz by root over tan x. In place of tan x we put z, that means tan square x equal to z square plus 4 equal to 2 square. So it is in the form integration dx by root over x square plus a square equal to log mod x plus root over x square plus a square. Dx by root over x square plus a square equal to log mod x plus root over x square plus a square plus c equal to log mod z means tan x plus root over tan square x plus 4 plus c. Now, I think you understood everybody. Now, another math number 13. I start here. Integration dx by root over x minus 1 into x minus 2. First, dx by root over, if you multiply these two you get x square minus x minus 2x means minus 3x plus 2 equal to integration dx by root over a square minus 2ab plus 3 by 2 whole square plus 2 minus 3 by 2 whole square means 9 by 4 equal to integration dx by, students notice everyone, x minus 3 by 2 whole square, it is plus 8 minus 9 means minus 1 by 4 means minus half the whole square. So it is in the form, what is the form? The dx by root over x square minus a square equal to dx by root over x square minus a square equal to log mod x plus root over x square minus a square plus c, log mod x plus root over x square minus a square plus c equal to log mod x minus 3 by 2 plus, and this is x minus 3 by 2 whole square minus 1 by 2 whole square come from this. That means x square minus 3x plus 2. So in place of x minus 3 by 2 whole square minus half the whole square equal to, we put x square minus 3x plus 2 plus c. In this way, from this exercise, rest of the math you solve. Now you see, I write here some form of integration. If you see that integration given in the form this way, this 5 ways, then at first what do? You do, if the integration given in the form px plus q by x minus a into x minus b, where a not equal to b, then you rewrite this form in this way: a by x minus a plus b by x minus b. If in the form it is given in the form px plus q by x minus a whole square, then you rewrite this integration in the form a by x minus a plus b by x minus a whole square. If you see that it is given in the form px square plus qx plus r by x minus a into x minus b into x minus c. Then you rewrite this in the form a by x minus a plus b by x minus b plus c by x minus c. If you see that it is given in the form px square plus qx plus r by x minus a whole square into x minus b, then you rewrite this in the form a by x minus a plus b by x minus a the whole square plus c by x minus b. And at last, if you see that it is given in the form px square plus qx plus r by x minus a into x square plus bx plus c, then you rewrite this in the form a by x minus a plus bx plus c by x square plus bx plus c, where x square plus bx plus c cannot be factorized further. Remember, where this form x square plus bx plus c cannot be factorized further. Okay, now within this form I solve few integration and you solve rest of the problems in your home. Okay, now from exercise 7.5 as per NCERT book, I solve few problems. Integration x by x plus 1 into x plus 2 dx. I write this in this way. X by this form which I discussed just now, x plus 1 into x plus 2 equal to a by x plus 1 plus b by x plus 2. So x equal to a into x plus 2 plus b into x plus 1. Therefore, x equal to a plus b into x, ax plus bx, a plus b taking common x, plus 2a plus b, 2a plus b. Comparing both sides, what you get? Now a plus b equal to 1 and 2a plus b equal to 0. It is constant term and here constant term not present here, so therefore constant term equal to 0. You can write this is equation number 1 and this is equation number 2. Subtracting one from 2, we get a 2a plus b equal to 0 and minus a minus b, b cancel, that is in this way, 2a plus b equal to 0, a plus b equal to 1. So by subtracting a equal to minus 1 you get. Now understand students, so a equal to minus 1 and from 1 we get, if you put a equal to minus 1 then b equal to 2. Okay, then b equal to 2. Now put the value in here. So integration a by a means minus 1 by x plus 1 plus b by b means 2 by x plus 2 dx. So minus log mod x plus 1 plus 2 into log mod x plus 2 plus c. C equal to integration constant. So log mod this equal to, we can rewrite this in this way, log x plus 2 whole square. So log x plus 2 whole square minus means divided by x plus 1 plus c, x plus 2 whole square, x plus 1 plus c. Understood? Now I erase this. I solve few more problems. Now on another math, integration x cube plus x plus 1 by x square minus 1, x cube plus x plus 1 by x square minus 1 dx. I divide numerator x square plus x plus 1 to the denominator x square minus 1. Sorry, it is x cube. So x multiply x cube minus x. X cube minus x cancel 2x plus 1. So it is equal to, you can write this in this way, x whole, that means x plus 2x plus 1 by x square minus 1. So I write here integration x plus 2x plus 1 by x square minus 1 dx equal to integration x dx plus integration 2x plus 1 by x square minus 1, that means x plus 1 into x minus 1 dx. Now 2x plus 1 by x plus 1 into x minus 1 equal to a by x plus 1 plus b by x minus 1. So 2x plus 1 equal to a into x minus 1 plus b into x plus 1 equal to a plus b into x plus bx, and here minus a plus b. So plus or minus a minus b, that is equal to minus a and minus plus b. Comparing both sides, what you get? Now a plus b equal to 2, and constant term a minus b, minus a minus b equal to 1, that means a minus b equal to minus 1. It is 1 and it is 2. Subtracting 2 from 1, we get a cancel, b, minus b minus plus b, that means 2b. 2b equal to 3, that means 2 plus 1, b equal to 3 by 2. So from 1, a equal to 2 minus 3 by 2. A equal to 2 minus 3 by 2 equal to 1 by 2. So you put this equal to integration x dx plus integration a means half into dx by x plus 1 plus b means half. Now b means 3 by 2. Here b 3 by 2, a half and b 3 by 2. B equal to 3 by 2 into integration dx by x minus 1. This x and this equal to that. So a by x plus 1, a equal to half into dx by x plus 1 plus b by x minus 1, b equal to 3 by 2. 3 by 2 into integration dx by x minus 1 equal to x means half x square plus half log mod x plus 1 plus 3 by 2 into log mod x minus 1 plus c. What is the answer? I think students, you understand, everybody? Now on another math. Next math. Integration cos x dx by 1 minus sin x into 2 minus sin x into 2 minus sin x. Integration cos x dx by 1 minus sin x into 2 minus sin x. How you can solve this problem? So just you notice, if you carefully notice, you see that ddx of sin x, that means derivative of sin x equal to cos x. So if we put z in place of sin x, then you get cos x dx equal to dz. So we put z equal to sin x. So dz equal to cos x dx. So integration cos x dx equal to dz by 1 minus z into 2 minus z. You can write either a by this plus b by this, that means a by 1 minus z plus b by 2 minus z in this way, or you can do another way, just in this way. If you rewrite this in this way, 1 by 2 minus z or minus 1 by 1 minus z, then 1 minus z, 1 minus z or 1 minus z minus here 2 minus z. So 1 LCM 1 minus z into 2 minus z, LCM match, and numerator you see what happened. Now numerator 2 minus z minus 1 minus z, minus 1, and that means minus plus z. Okay, 2 minus z minus 1 minus plus z, z cancel, 2 minus 1 equal to 1, match. So you rewrite this in this way. It is very simple process. It is equal to here dz. So it is equal to dz by 1 minus z minus integration dz by 2 minus z equal to dz by 1 minus z. That means minus log mod 1 minus z minus dz by 2 minus z equal to minus log mod 2 minus z. That means minus minus plus log mod 2 minus z plus c equal to log mod 2 minus z by 1 minus z plus c equal to log mod 2 minus z. Z means sin x. 2 minus sin x by 1 minus sin x plus c. C equal to integration constant. In this way, rest of the problems you solve. So that's all for today. Thank you.